Company will get it 33%. So not more than
you know to find myself
welcome again. One of the most astonishing things about this evening is that almost all of the people who RSVP'd actually showed up. This shows you the appeal of Professor Laker, all right? Because this is not known, this is not common in Israel, and also the people who are here. I mean, it's really an honor for Shoshana and I to host all of you in our home this evening. You know, I've been involved now for 20 years or whatever in various startups and universities here and whatever, try to do something to make a contribution. And the combined contributions of the people in this room today are astonishing. I mean, it really is something amazing, and I thank you all for what you've been able to do, and thank you for being with us this evening. This is really an MIT evening, which I hate to say since I'm not an MIT graduate. They turned me down, actually. Did I ever tell you that? I still don't understand. It must have been a mistake. But the thing that sort of brings us home.
They can give you an honor or a PhD. That's true.
I'll contact them again. They can make up for their mistake. Very good. The MIT Forum is, and we have a number of other advisors and directors here. Yes?
Right.
Who are with the forum? Yeah, so thank you, all of you. It's a great institution. We try to do our best on a very thin budget, but Ella Madeline, who has been the director there forever, does a great job. And the thing that's kind of bringing us together today is that first we have a group of exceptional entrepreneurs from young entrepreneurs from Greece here who were sent here for a sort of a mission to Israel to visit with the startup nation and whatever. And one of the sponsors of that mission is the MIT Forum. And also this is the MIT Forum, not in Israel, but worldwide. It's the 40th anniversary. So we're kind of combining all of these things into an event, which of course the primary reason for doing this was to be able to host and talk with and listen to my long-term friend, associate, Professor Robert Langer. I'm not going to attempt to go through what he has accomplished in his lifetime or what the things he's working on now. I have no idea what he's going to talk about, but I'm sure it'll be interesting. Before Professor Langer, I would like Ella to say a few words. Is that all right? Great, thanks.
Martin and Shoshana, and it's wonderful to be on the same stage with these two guys. And I'm very happy to be part of the Yezmot Enterprise Forum. Martin had to go to Harvard, right? And it's a great opportunity to have Professor Robert here with us. I would like to thank the American Embassy for making this possible, and thank each and every one of you for being here. The MIT Forum was the first chapter. The MIT Forum of Israel was the first chapter in the MIT Enterprise Forum, Inc., outside of North America. This happened in 25 years ago almost. And since then, the organization has become much more international. So now it's about half the chapters that are outside of the United States, including a chapter in Greece, in Mexico, an excellent chapter in Lebanon, the Pan-Arab chapter, all working on providing skills and know-how and capabilities to entrepreneurs. And some of the people here in the audience were our clients throughout the history of the MIT Forum in Israel. So thank you again for hosting us. Thank you so much. And enjoy. Thank you.
Professor Langer.
Thank you, welcome, and thank you for having me. First, I just, I'll talk a little bit about myself, but in a minute. But I just first wanted to thank Martin so much for this first, the incredible wine and food. It's just amazing, and this beautiful house. I also wanted to say, because people may or probably do know, but in case you don't, there could be no better person here to host something called an Enterprise Forum. I mean, Martin himself is an unbelievable entrepreneur, being as a CEO, making it an unbelievably successful company. I still told him when I saw him tonight, I must have been in Israel with him over 30 years ago where we were giving talks. And he gave one of the best talks I'll ever remember. He was talking about, and this is true, and I'm going to go over my own life in a different way, but sort of the ups and downs of Alza and how certain events, he actually talked about some of the things that happened, and if a good thing happened, the stock went way up, and he showed the numbers, and if a bad thing happened, the stock went way down, he showed the numbers. Fortunately, overall, it kept going up. But the thing is that's a lot about what happens in these areas, and he did an amazing job of making it successful. But he also did an amazing job, at least to me, of bringing that to life. And that was actually before I even got involved in starting companies. And part of the message I guess I was going to give, and actually something I wasn't thinking about saying, but I will, is that so much of what we end up doing, at least for me, has been about failing and not doing so well. So actually, just to compliment what Martin said, I actually applied to MIT also as an undergrad, and they turned me down too.
I feel much better
today, I'm one of MIT's highest honors, being a student professor, and I'm an institute professor. I've been that for 14 years. But I got turned down, and it was really, it was depressing to me. So I know exactly how you feel. But I think the important thing is the first thing that happens isn't the last, and you just keep going. And I'll go over a little bit, about sort of my own career and some of what I tried to do and different things. And then maybe we'll talk and have a discussion. People can ask questions, make comments, whatever. So for me, I won't start when I applied to MIT and got rejected. I'll start a number of years later and tell you about how I started thinking about my own career, since so many of you are young people. So when I was a graduate student, it was I finished my degree in 1974. And in 1973, and I was a chemical engineer. And what happened around that time is there were this gas shortages and the price of gas going up and up. So pretty much all my friends, they applied to oil companies because there were so many job offers in oil companies, and they paid these enormous amounts of money. And so that was what almost my entire class at MIT did in 1973 or 1974. And I was a pretty naive kid. I thought, well, I'll do the same. So I applied to different companies. I actually got 20 job offers, 4 from Exxon alone. But, and like I said, my friends took them, and I'd go there, and, you know, I'd start to think about, you know, one time I remember going to Exxon in Baton Rouge, Louisiana, and I went there, and I remember one of the chemical engineers said to me, you know, gee, if you could just increase the yield of this one petrochemical, said it'd be worth billions of dollars. And I just thought, that's boring, you know, and I didn't want to do it. And I remember flying back to Boston that night thinking to myself, I wasn't going to do that. And so I didn't. Even though I got those offers, I decided I was going to not do something like that, because I somehow had in my mind I wanted to make more of an impact, you know, than just increase the yield of something by 0.1%. So, you know, one of the things I had done when I was a graduate student, I was very interested in education. And when I was supposed to be doing my PhD thesis, I spent a lot of time starting a school for poor high school kids in Cambridge. And one day I saw an ad, and I got involved in developing new chemistry curricula, new math curricula. One of the things that concerned me is I felt like a lot of curricula was also not that exciting. You could make it more interesting, and every one of these kids was a high school dropout. So one day I saw an ad to be assistant professor at City College of New York, where they actually wanted people to do the same thing, develop new chemistry curricula. So I was very excited about that, and so I wrote them a letter applying for a job, but they didn't write me back. So I thought, okay, well, I'll find all the ads I could to do something like that. Found about 40 of them, and I wrote to all these schools, and actually not one of them wrote me back. You know, and I probably wasn't in the right box, you know, like I didn't study chemistry education. Even though I actually loved doing what I was doing, and I think I was pretty good at it. So that wasn't working, but it still started making me think that I wanted to use my chemistry education chemical engineering education to help people. So the next thing I thought about was, well, maybe medicine. And I knew absolutely nothing about medicine, but I thought that could be a nice thing to do. So I wrote to a lot of hospitals and medical schools. They didn't write me back either. One day, one of the people in my lab, when I walked in, he could see I was discouraged, and he said, well, about that, he said, well, Bob, he said, there's a surgeon in Boston named Judah Folkman. Judah Folkman, by the way, would win the Wolf Prize in 1991, later on, but this was 1970. So anyhow, he said, you know, sometimes he hires unusual people. He thought very highly of Dr. Folkman. I won't say what he thought about me. So anyhow, I wrote Dr. Folkman applying for a job, and he was nice enough to offer me a job. Didn't pay anything like Exxon or anything else, but I didn't care because I thought he had an amazing idea. So his idea was that if you could stop blood vessels, he thought you could stop cancer, because he felt blood vessels would feed the tumor. If there's some way to stop them from growing, maybe that would be a new way to think about treating cancer. And I thought this was just, you know, as I listened to him and talked to him, I thought this was just terrific. I had no idea. It turns out almost everybody in the biology area thought this was a terrible idea. But I didn't know any biology, so I thought it was great. And I really liked him. And it turns out, by the way, he was right, and they were wrong, so anyhow, I went to work there, and I got involved in two kind of related problems. One of them was trying to find a substance that would stop blood vessels from growing, because it had never been done, and that would prove his theory. And I thought it would also I could hopefully, you know, lead to new kinds of treatments. And tied to that, whenever you do something like this, you have to have a way, we wanted to develop what we call bioassays, a way to study blood vessels from growing. And the thing is that almost every way you try to study blood vessels, it takes about 3 months for the blood vessels to be visualized so you could do this. And one of the problems is that when you try to do this, we needed a tiny little system that we could put in anything we were isolating and have it deliver slowly the molecules that we were isolating for these 3 months. And the problem was all these molecules we were isolating were really big molecules, like proteins. So actually, this is actually how I first met Martin. Dr. Folkman, the only company in the world that was doing anything even closely related to the second part was Alza, which Martin was president of at the time. And so Dr. Folkman was on their advisory board. And he talked to different people, but people basically told him that was a really tough problem. And they said, by the way, even if you look at the scientific literature, they'll tell you that a large molecule isn't going to be able to move through a piece of plastic. And so sometimes I say the only reason that we ultimately managed to succeed at some of this is that we didn't know any of the literature. And so anyhow, what I began doing is developing certain types of plastics that could deliver these large molecules. And what would happen is, after many, many years of failures, I always say I found over 200 ways to get this to not work. We were able to do this. We published 2 papers in 1976. One was on these plastics that could release these large molecules. We published that in Nature. And the other was actually on the isolation of the first blood vessel inhibitor, which we published in Science. And I was very excited about that. By the way, just for the academicians in the audience, it's very interesting to me. Those are 2 of the top journals in the world. But the one that was published in Science, we first sent to Nature, and they rejected it. And the other one, that was published in Nature, the one that was in Science, Nature rejected, and the one that was in Nature, Science rejected. And so neither did we get right the first time. And they ended up becoming, very important papers. And by the way, and I should also tell you, some part of this I wish I didn't have to say, but this is what happens in medicine. So the Science paper on the first blood vessel inhibitor, that was 1976. It took another 28 years from that paper before the first blood vessel inhibitor was approved by FDA. And it took literally billions of dollars worked by many companies like Genentech, actually using a lot of the techniques that we developed, but it took 28 years from that paper before the first angiogenesis inhibitor was approved. That drug, the first one, was Avastin. That's still today, 15 years later, the 4th largest selling drug in the world. And some of its derivatives, Eylea and Lucentis, end up being today the only treatments for diseases of blindness, the only, I should say, pharmacologic treatments for diseases of blindness like macular degeneration and diabetic retinopathy. But it took enormous amounts of perseverance and effort by all kinds of people. At any rate, just to continue a little bit on my career, so I'm going to go back to 1976. So, we wrote those papers, and I loved being a postdoc in Dr. Folkman's lab. I just thought it was tremendous. I was actually the only engineer in Boston Children's Hospital where I worked, and I thought it was really great. But a lot of my friends told me, it's probably not good to be a postdoc your whole life. So I did a couple of things. One is I started writing research grants. And if you're an academician, you write research grants, and generally you write them to the government, NIH. And my first 9 were turned down. I remember writing one on cancer and angiogenesis. And one of the reviews came back is that this grant should be rejected. They said, Dr. Langer is a chemical engineer. He knows nothing about biology, and even less about oncology. Now, I thought at least I knew enough about math to know that that wasn't quite possible. But it didn't matter. I mean, they were calling the shots. And I actually got, like you say, 9 grants in a row rejected. And then, I started applying for faculty positions. And like I said, I'm a chemical engineer. But not a single chemical engineering department in the United States would hire me. They said this kind of biology, medical stuff I'm doing makes absolutely no sense for a chemical engineer. We shouldn't hire you. So I didn't. I got no jobs like that. But Dr. Folkman, once, one of the people he knew who was also on the ALSA Scientific Advisory Board was a man named Nevin Scrimshaw, who was a very famous nutritionist. And Dr. Folkman introduced me to him, and Nevin Scrimshaw, he was like what I'll call sort of a benevolent dictator. For the department. So he met me, he liked me, and he decided he wanted to hire me, but he never bothered to ask any of the rest of that department what they thought. So, at any rate, I got this appointment in the nutrition department as an assistant professor, and actually even him doing that would have been okay, but the only problem was the year after I joined that department, as an assistant professor, Dr. Scrimshaw decided to leave the department. So then what happened was, unfortunately, that a lot of the senior professors in the department decided that I should leave the department too. And I always have this story that one of my good friends, Mike Barletta, who was ultimately chairman of Berkeley's chemistry department and President Scripps said, he explained the story, one day, a bunch of junior professors like me and him, this is 1979, 1980, went to a restaurant with a bunch of senior professors, and he said, there's Bob explaining some of his ideas on drug delivery, and he said, and there's this senior professor smoking a cigar and blows a cloud of smoke in Bob's face and tells him, you better start looking for another job. And that's all true. But I kind of kept at it and working on these things. And eventually, I didn't lose the job, obviously, at MIT. But it was really a struggle for a long time. Another thing that I started thinking about when I started doing some of this work is I would write papers, that's what you do in academics. And people would cite our papers. I've been cited a lot, but I really wanted people to use the things that we did. And so what happened was I remember we got a patent on something, actually was in a drug delivery thing, and we ended up licensing it to two very large companies, multi-billion-dollar companies. And I still remember being very excited about this because they gave me a consulting agreement, they gave our lab a big grant, but most exciting to me was that they said they were going to work on it and develop it. But the problem was these large companies, they did a couple of experiments, and they didn't work out that well, so they just gave up. And that really was discouraging to me. And then one day, one of my friends, Alex Klebanoff, a professor at MIT, said, Bob, we should start our own company. And so we did, and 4 of my students joined me in doing this. And we started this company and ended up doing very well today. Merge is now, they have products that, they have about 2,000 people, products that, millions of people use. And that was a very exciting experience to me, and also I think to the people in the lab. And so, even though a lot of people in academics in the 1980s felt this was not a very good thing to do, we just kept doing it. And today, we've ended up, and pretty much all the things we've done, have been in that model. We've had people work 4, 5, 6, 7 years in the lab on things, and then we have these students who really care about what they've done, and they've started a company or things like that, or they wanted to start a company to see their work get out to the world. So, we've kept doing this, and some have worked well, some have worked less well, but overall, they've led to products that affect many, many millions of people, and I think and many jobs. And of course, ultimately, it's not just me. One of the things that to me has been very also exciting is when I look at the area around MIT, what's called Kendall Square. When I was a graduate student, it was a slum. It was a place where there were no hotels, no restaurants. The only thing that they had were a couple bars that weren't very good. And it was really not a very nice environment. Today, that area, because of not just me, but lots of other people, has the highest concentration of biotechnology companies in the world. Probably a market capitalization of, I would imagine, well over $1 trillion. And because of that, everything else has come with it. There are tons of hotels, the best restaurants. I remember a couple of years ago, the Boston Globe, which is a major newspaper, listed the best restaurants in Boston. In the greater Boston area, out of the top 57 were, 4 blocks from my office. Which, like I say, and it continues to be like that. So the area, and it just keeps happening and happening, and I think it's just been a wonderful career for so many people. And for us, there's been really a whole diversity of different things. We've done stuff in drug delivery, we've done things in new drug development. Some of the newer companies that people may have heard about, recently we started, well, I shouldn't say recently, we started a company called Moderna a few years ago, which went public in, which is messenger RNA and nanoparticles, and that went public in December, which was the largest biotech IPO in history. I hope it'll do well, but they're in 10 clinical trials with, I think, very transformative technologies for cancer and heart disease. We've gotten involved in new diagnostics using nanotechnology. We've gotten involved even in the food area, even in the cosmetics area. We got involved in starting a company with Jennifer Aniston, who, in hair care, which ended up doing very well. And some have, some haven't. but by and large, it's been very exciting for me to see our students get involved in these things, to create new products and have, you know, really great careers. And to see the technology that comes out of MIT, you know, not only lead to new companies, but products that really can transform society. So anyhow, I'm going to stop there, but I just thought I'd go over those kinds of things. Like I said, I've had probably many, many more failures than successes, and I think that's kind of what happens when you do research. But, you know, I think you keep pushing and pushing, and hopefully don't give up, and I think that's kind of part of what I wanted to say to the young people in the audience. So let me stop here, see if there's any questions that I can answer. Thank you. Yes?
What would you advise MIT regarding the selection process for the students for their first degree?
Well, they certainly should have accepted Martin and myself. But, you know, I mean, it's very hard. You know, I mean, I remember when I applied to MIT, and then I even had an interview. And I remember, like, the interview, the guy, he said, well, what do you want to do when you're done with MIT? I mean, you know, and I remember thinking about, and then he asked a lot of hard questions like that. I mean, I didn't have a clue. You know, I didn't know what I wanted to do. You know, I mean, I think, though, I think it's very hard to figure these things out. You know, I certainly, I don't know how you can measure, you know, I don't know how you can measure things like, you know, you can see how people do on aptitude tests. But I don't know how you can sort of measure what I'll call perseverance and guts and vision, you know. I don't think, you know, I also would say another thing, you know, sometimes people ask me, what do I feel, you know, when I'm a professor, you know, what do I look at I do? And one of the messages I offer, and this won't exactly answer your question, but I think it's an important thing to realize. So, you know, one of the things I say to people is, you know, when somebody's in grammar school, high school, college, they are judged entirely on how good their answers are to other people's questions. You know, and yet, if you think about it in life, I mean, it's good to be able to give good answers, but what's really important is to be able to ask good questions. And so I kind of feel part of my goal when I'm a professor advising graduate students and postdocs is to help them make a transition from somebody who can give good answers to somebody who can ask good questions. I mean, and actually, I look at it, I have two of my postdocs are here, former postdocs are here tonight, you know, Avi Dom and Gershon Golem, and I mean, they were postdocs with me in the 80s. Both of them actually not only came to Israel and at Hebrew University to be professors, they actually have been deans. You know, I mean, they've been incredibly successful and in every way. But I just feel that is, you know, I don't know how you judge. You know, no standardized test really measures creativity, no standardized test measures perseverance. But I think that is part of the issue. By the way, I still think, in spite of their errors on Martin and myself, MIT admission still does pretty well. But it's, you know, but I don't know really how to answer it. I think every school, unfortunately, you know, suffers from that. And you know, and so I just think that's sort of the nature of the beast. People use these standardized tests. Yes, Mark?
Yeah, it's interesting for me listening to you because so many of the sort of the issues that you dealt with and the things, how you made decisions, I think I also kind of followed the same rules. It's interesting, for my career, I ended up having sort of two general kind of concepts. One is, don't get involved with anything unless you are absolutely convinced that if it fails, you'll be glad you did it. All right? That it's easy to get involved with things that, you know, if it's successful, it will be great. But you know what? Life is short.
Yeah.
And you don't want to do things hoping that they're going to be, you know, if they're successful and they make $1 billion. Do something that you think is valuable.
Right.
And it's a big enough world and there's enough stuff out there that most likely you're going to do fine. In any event, you're going to be happy about what you did. The other thing is that, and this is something that I learned from the guy who I learned almost everything from, Alex Zaffaroni, and it's very clear that you're a great example of it. And that is where, from an industrial standpoint, you know, for to create companies and to create real value. In today's world, most sciences, most technologies are so far advanced that the opportunity for you to go in and sort of take it to the next level is probably very, very low, all right? On the other hand, the other thing that has happened with the way technology has developed, it's all developed in silos. People don't talk to one another,
Right.
all right? And I mean, I can say it now, but you know, I would have never said it when Alza was a $10 billion company. Alza was a company that was a combination of engineering and medicine, pharmaceuticals, all right? That's what we were. We brought together those two things, which at the time, other than what Bob was doing, really, I don't think there was anyone else on the earth that was seriously being done, all right? So there was a point when we had 2 or 3 of the top 10 drugs in the world. We had to create a drug. The amazing thing is that if we had a professional engineer come into our company and say, we want you to judge the engineering capability of your company, they would have left laughing. They would say, this is a joke. They have membranes that they're letting chemicals go through. People are sending spaceships to the moon, all right? First year engineer in any school in the country could do from an engineering standpoint what this company is doing. This is crazy. Bring in a great pharmaceutical person to judge our company. They would walk out laughing. They say, this company knows nothing about any diseases of any substance, knows nothing about any biological pathways, knows nothing about, specializes in any diseases. How in the world, what's amazing though is that no one ever brought these two capabilities together, all right? We took known drugs and made them administer better. So they were superior products, multi-billion dollars, all right? Had we set up the company based on our engineering capability or based on our pharmaceutical, we would have been a failure. The issue was every decision that was made, it was forced these two groups that didn't speak together even. They spoke different languages. You were fortunate because you had both in one head, all right? In most situations, it's not that way. At Compugen, the first company I was really involved with in Israel, the most difficult thing was to get biologists and mathematicians to respect each other. Realize they don't respect each other. A mathematician looks at now it's different in today's world, but 20 years ago, a mathematician would look at a biologist and say, how can he call himself a scientist? He throws chemicals at animals and writes down in a notebook what happens. How can that be called science? This is ridiculous, all right? And of course, a biologist would look at a mathematician and say, if it can't be reduced to numbers, this guy doesn't think it's important. He's got no view of the world, no breadth. It's a joke. Of course, and in the beginning of Compugen, I'm sure it's different now, but they really didn't respect each other. It took years to get them to rely on each other. And so I would just urge those of you, particularly, sorry to give another lecture, but for those of you who are, thinking about companies and moving forward with companies, whenever you ask a question whenever you have a problem, that you need to solve, the first question to ask is, where is the best technology in the world to solve that problem? All right? Forget what your technology in your company is. Don't try to force your technology to solve the problem. Step back and say, okay, here's a problem we weren't anticipating. Do we really want a chemist to be looking at this? Or is this a problem of physics? Or is this a problem of engineering? Most companies don't do that. It's amazing. Anyway, sorry for the...
No, I think it's great. And by the way, your point, just to broaden it a little bit, I see this in academics, if you have been for years, and still 99% is what I'm going to say is still the case. If I look at this at universities, almost always what you see is there's a building for math, a building for English, a building for biology. So one of the things actually I remember thinking, for me, I was, the only engineer actually in the hospital. And one of the things MIT did, a number of years ago, partly because we suggested, is they built a building which is half biologists and half engineers. But if they tried to do that in the 70s, and still most people think that's a terrible idea. But I think that what you said is exactly right, because it gets people to talk to each other in different ways, students to talk to other students in different ways, and actually the number of companies that have come out of our building have been tremendous, and because, in part because of that, because you think about new kinds of things. In fact, just as an example, one company that I've been involved in with Phil Sharp, who is a great biologist, a Nobel Prize winner, so there's a company called Alnylam, and Phil, of course, this actually relates to drug delivery. So one of the discoveries that actually won a Nobel Prize in 2006 was the discovery of what's called siRNA.
Excuse me, 2006 was a great year for Merlot in Israel.
The Golan Heights. What I was going to say about 2006 is second importance.
That's great. So anyhow, people discovered a way to sort of silence the gene. And, a number of us got involved because we thought this might be a whole new kind of, way to make new drugs. And so what's happened is there are a lot of challenges. One is, of course, the biology, but the other, of course, is the delivery. And this is actually even more complicated delivery because you have, RNA is a pretty big molecule, but you have to target it to a certain place. And for that, you end up using what are called nanoparticles, which was something that, I would help contribute on. And what's been really exciting is in last year in August, maybe that was a good year time too, but Alnylam got the first FDA approval of any agent like that. There's a disease, it's a protein misfolding disease called ATTR amyloidosis. And basically using a RNA directed it with a nanoparticle that moves it to the liver, they were able to shut the gene down that causes that, and it just had an amazing positive effect on patients. So that leads, we'll end up saving, a lot of lives. Alnylam's been an incredibly successful company. It's worth about $6-7 billion, maybe more. But it's an example of combining biology and engineering, that came out of things that Phil, myself, other people got dead. And so I think, but there are a lot of others. There's actually a nanotechnology company we started called T2 Biosystems, which is public, and that came out of a grant that a number of us wrote. Tyler Jackson's head of the building. It used to be, just for example, people have and I had this myself, if you've ever had a blood infection, what happens is you have to, you might get what's called sepsis, and you may die. And they don't know usually what antibiotics to treat it with because they don't know what bacteria are there. So what they normally do is they take the blood and they grow it out, but it takes about 5 days. And so when that happens, they don't know how to treat you. And in that time, there's something like 90,000 deaths a year. But using this nanotechnology approach that we ended up developing with Tyler and others, now you can, just got FDA approved, now you have a bacteria panel so you can detect it in 3 hours. And so, that's a public company done well too. But the thing is that so many of these things come from doing just what Martin said, combining sort of engineering and biology, which, like I said, you said, used to be something, and I think still is to most places, that a lot of people think doesn't make any sense. Anyhow, we'll go, yes.
In Greece, we face a big problem that other countries and other business ecosystems already sorted many decades ago. The connection among research, academia, and business, because they don't want to talk together somehow. Do you have any suggestion for incubators, accelerators, the other parts, of the liver? How, maybe a secret sauce, and this is a question for all the audience, how we should make a short, to give some solutions in order to bring them together and to make join academia and also the businesses, the corporations.
Yeah. Well, let me just, I don't have the answer, but I have a couple of things that I think might be worth saying. I think that I mean, I think that's a problem everywhere. You know, I don't think it's limited to Greece myself. But one of the things that to me, I always think about the United States is that, and I think people are slowly starting to realize is that it's very interesting to me that if you look at where there's been this enormous economic growth of startups that have become unbelievably successful, there's two places in the United States where it's been incredible. One, actually, is where Martin was, the area right around Stanford, you know, which ends up being Silicon Valley, and the other right around MIT, which is Kendall Square and the greater Boston area. And interestingly, it's not the bigger cities, I mean, that are much bigger, like New York, Chicago, Houston, Los Angeles. I mean, they're nothing close to those two areas. So what makes those two places stand out? I mean, to me, and again, it'd be great to get other people's thoughts, but those are two of the top universities in the world. Secondly, usually they're ranked 1 and 2 in engineering, you know, so there's this kind of engineering culture. And so, you know, and when you have that, people do want to feel it's actually sometimes a good thing, or at least enough of the people might feel it's a good thing to make technology transfer happen. So I always tell people in different states when I've been asked to speak to by a couple of governors or even countries, I always say, well, you know, you really, I think one thing that's important is to really make sure that the universities are great. And I also feel engineering is very, very important to have in some capacity. But that may just be a starting point, you know, what I'm saying. But I think if they don't do that, you know, then, you know, and it's interesting, then you look at other states in the United States, you know, like Wisconsin and Illinois both have cut their budgets to two very good schools, the University of Wisconsin and University of Illinois, by $300 million. I expect that'll have long-term negative effects to them. Again, I'm probably speaking as an academician because that's what I am, but I think that those are some things that are important. Maybe other people should want to add.
Thank you very much.
Thank you very much.